How are you guys doing? So I'm gonna go ahead and get started here. It's 11 o'clock Eastern time. My name is Ahmad Stokes, one of the senior managers here at VisonNav Robotics. I'm going to do a overview of our technology of VisonNav here shortly. Let some more people filter in. I know we're supposed to start at 11 to 12, and I want to be mindful of everyone's time here, but make sure that we'll kick off at a correct time. So what you're going to see here today is overview of our technology and also showcasing our demonstration of our AGVs, both our VNR and VNE autonomous lift. So really excited for this opportunity today. Without further ado, I'm gonna go ahead and share my screen. Hopefully, you guys can see this presentation once I share, and then I'll go ahead and do a quick overview of our technology, and then we'll start showcasing our vehicles. So VisonNav Robotics, we're a global provider of AGVs and AMRs. Really excited to bring these products to the North American market. We've been in North America for close to 9 months now, but we are a very growing and excited organization here to present to you guys today. So across the platform, we have over 500 employees with 70% in R&D. So what does that tell you? That tells you that we're already thinking about the next generation of our technology, right? From use cases to software updates and really bringing advantageous scenarios to your facility. So right now I'm in our demo space here in Ackworth, Georgia, about 35, 40 minutes, depending on traffic right here you're talking to that day, just north of Atlanta. So I'm here in the demo space, what you see here in the screen. This is our North American engineering and solution team from back in March. I'm not in this picture. I recently joined the organization in late May. We're really excited to showcase these vehicles today with you guys. From a global standpoint, we are a global entity, right? So our North America headquarters is here in Atlanta, as I mentioned, as well as our parts depot where I'm located right now. But we span across the globe, East Asia, Australia, the European market, and Japan. So really excited. Again, we've hardened our products and our deployments across the European, overseas market and Asian market. Now we're here to bring it here to North America. So really excited for these opportunities. Uh, so when you think about autonomous guided vehicles and the technology, top level organizations are utilizing 3D lidar and SLAM algorithms. So what does that mean? We're a natural feature deployment. So when we deploy our AGVs, we do not require really stringent, hard materials to navigate and deploy. Right. So you think about traditional LGVs or AGVs with wire guided laser reflectors, magnets on the ground. That is not the case for us. We actually use 3D lidar. Lidar standing for light detection and ranging, using the SLAM algorithm, simultaneous localization and mapping. So simply put, what we do is we drop off our robots that you see here on your screen to the right, and we drive around your facility and we map both like columns, walls, uprights, even the ceiling with our technology. Because ceilings, right, they never really change from a day-to-day operational standpoint. And that we use cloud point, right, detection to map the facility. We take that 3D map and we place nominal paths and pick and drop locations onto that 3D map. And that allows us to get high flexibility, high accuracy, plus minus 5 millimeters for indoor accuracy and travel. So that's how we navigate and map the facility on deployment with zero infrastructure. Uh, our perception here at VisonNav is top notch. I think personally, this is where we separate ourselves from, the competitive space. Is that we don't just focus on, perceiving standard wooden pallets with pocket holes. We have the ability to detect and perceive automotive cage rackings and manufacturing racks and tier racks as well. So we're going to be showcasing this today in that perception. And we use a combination of photoelectric, ultrasonic, and 3D image sensing to specify different specifications of the pallets, pocket hole orientation, and really have high accuracy, plus minus 3 millimeters. So really excited to showcase this today, especially for you automotive and manufacturing providers, or even in fulfillment centers or distribution centers where you guys have maybe smaller or unique payloads that you're moving throughout your facility. Our RCS, which I'll talk to a little bit, is our robot control system, right? What we do is we're fleet management of your deployment. We can tie into your upper system WMS or ERP system using our open API, and it's a one-stop shop for mapping, tracking, utilization, understanding error or maintenance reports. It's your one-stop shop. So we can give out individual ID, passcodes, and user profiles, and you can have maybe a robot wrangler at your site to have all the dashboards to check, utilization and run your own analysis. Or you can have, decentralized, smaller individuals who are maybe tracking one subset, right? And we can customize dashboards to give you guys complete, visibility of your AGV fleet after deployment. And it's via desktop, tablet, iPhone, whatever the case may be. And here are some visuals of our RCS dashboard. If you guys ever want to reach out to me and get a live demonstration of this, we can definitely set up that call, and we can have a one-on-one call and kind of walk through what our RCS platform looks like in real time. Our AGVs also tie into your facility infrastructure. So whether you guys have manufacturing conveyor lines, automated doors, elevators, ASRSs, or robotic cells, we can tie in using our PLC logic, photo eyes, remote triggers, smart IO to integrate to your facility infrastructure. We also have the really unique and cool ability to communicate with other AMRs, right, and AGVs. So you guys have maybe other smaller platform AMRs, or you've had deployed AGVs in the past, and you're looking for maybe more use case or more dynamics out of VisonNav, we can tie in, understand the interoperability protocol, and communicate for handoff. So really excited to bring this offering to you guys here from VisonNav. Obviously, I know with AGVs, there's always hesitance regarding safety, right? Safety is top of mind from EHS standards and operational leads on the floor. But just know VisonNav has top level safety certifications, both ANSI B56.5 here in North America and ISO 3691-4, the European standard. All of our vehicles are CE rated, which is a really tough certification to achieve, but we are CE rated. We use primarily SICK technologies from a safety PLC standpoint. And then we have our own isolated safety equipment, which we'll showcase throughout the demo today. From our safety laser, our fork height sensors, our good in place and fork detection, which is really critical, and emergency e-stops. And our vehicles, which I'll showcase also, has 360 coverage around the vehicle and 3 different levels of warning, right? We have a long range, medium range, and short range. Long range is going to fall within 2 or 3 meters, right? So if we're traveling on our nominal path, an AGV sees a static structure or a person in our way, 2 or 3 meters, we're going to slow down. So if we're traveling at 4 miles per hour, we're going to throttle back to maybe 3.2 miles per hour. If we're in that medium range, 1 to 2 meters, we're going to come to a turtle speed, and then anywhere in that immediate 1 meter, 3 feet around the chassis of the vehicle, we're going to come to a complete stop. And once that obstacle is removed out of our nominal path, we're going to continue on our workflow. So very comparable logic most AGV and AMR providers provide here in North America. But something that's really neat for an added layer of security that we have here at VisonNav is our UWB safety warning kit. And what this is that we have the ability to give your floor workers, site leaders, ID cards, wearable wrist straps, almost like an iPhone wrist strap, to be wearable. And we can set cues and proximity to the AGV in those individuals. We can even install UWB cubes on material handling equipment or infrastructure. So as I mentioned earlier, our standard logic is, we're going to stop 3 feet from the vehicle, right, roughly, 1 meter or so. But if your safety standard is, hey, I don't want an AGV within 6 feet or 7 feet of a person or a vehicle or this conveyor area, we can set that parameter, and that AGV will use that proximity sensor to navigate appropriately. So I'll play a quick video here to showcase this logic. So you'll see our autonomous stacker coming up on an individual wearing a safety vest with the ID badge. It references him roughly 9 to 10 feet out, and it stops. As that individual moves away, the AGV is going to continue on its workflow, right? So it's real-time measuring off of proximity to just give you guys that added layer of safety and security after deployment. So, as I mentioned, our overall solution structure is we can tie into your upper system, right? So whether you're using WMS with inventory tracking and barcode scanning, we use Open API, we're a Wi-Fi connected device. Our mid-level software is our robot control system. That's going to handle your fleet management, your tracking, tying into facility infrastructure, doors, conveyor lines, We can use PDA tablets to call missions for the AGVs as well. And then we have an optional bright eye system. I'm not going to dive too deep into it right now, but if you guys have some interest, please feel free to, after this call, to reach out to me. Our bright eye system is an optional AI visual learning platform, and we can monitor inventory in real time using AI visual. And is also an added increase of safety. So we can identify whether it's a manual person, a forklift, up to 99% accuracy, and notify our RCS of this activity in that staging area or on the floor. And then it won't allow an AGV to come into that working area. Why? Because there's a person, a manual forklift in the area. We can also tie it up to your RCS for mission demand. So you can imagine, a staging area getting unloaded manually by a forklift. And once those staging lanes are full, our bright eye system will recognize that visually and then send a system alert to our RCS, hey, AGV, clear out, staging lanes in dock door 1, 2, 3, or 4, whatever the case may be. Um, so now I'm going to dive into our hardware of our offering here at VisonNav Robotics. We are auto charge friendly, right? So we do not require battery swap or manual opportunity charging where you have to plug up and a lot of human touches, right? It's an autonomous solution. We want to make it zero touch for the humans after deployment. So the RCS will monitor the state of charge from between 80 and 30% state of charge, and then send the AGV to the charging location, self-park, self-dock, and charge. And as you can see on the screen, we support a multitude of VAC hookups, 280, 208, 480. So our autonomous fleet, as you see here, and what we're going to showcase today is going to be our E series, which is right behind me, and then our R series, which is our autonomous reach. So between the full product line, we have a tugger, a stacker, autonomous sit-down truck, autonomous reach, and then we have a slim stacker and jack as well. The carrier types are below here. To the far left on your screen, our stackers and pallet jacks really are focused on cages and closed blocked pallets. I'm sorry, open pallets. And then the REP are focused on those racks as well, but then primarily open face pallets with traditional forklift forks. And then we have our Q tugger to the far right of 10,000 pound capacity. So again, today we're going to be showcasing our VNE and then our VNR 16. Really excited for these vehicles to showcase you guys today. From a after go live deployment support, we have very comparable logic to most in this space. After go live, you'll get assigned an account manager, right? He or she is your main point of contact. Make sure KPIs, continue improvement, successes, and happiness is there after deployment. And any type of break fix, we can customize to your SLA standard, right? So whether it's, I need an on-site technician, parts consignment. You have in-house technicians where you need them trained to have some autonomy of the fleet. We can set that up as well. We have a 24/7 help desk, and we also have field engineers throughout the country as well. So if we have any, hard immediate break fix, a down auto kit, a sensor issue, something of that nature, we'll dispatch a field engineer to help us alleviate those downtime issues. And then we also have channel partners through service partnerships and integrators as well. So without further ado, about 13 minutes into the 1 hour demonstration, I'm going to go ahead and queue up the VNE 20 to do some automotive cage stacking. So you can go ahead and set it up. Yes. Yep, you can start. Yep, so we're going to go ahead and start the demo here. I'm going to stop sharing. Okay. And I'm going to go and step away here, and you're going to see our VNE 20. Go ahead and do some automotive cage pick and then stack. And we're going to start stacking roughly 3 levels high. So I'm on my laptop, guys, so I might have to move around a little bit to get better angles throughout this. I got Nicholas here right beside me, one of our solution engineers, and he's going to help me out to facilitate those movements. I also know we have a chat. So if you guys have any questions throughout the chat or anything, please let me know, and I'll answer them to the best of my ability at this time.
So the really unique thing about this is that we have the ability to perceive these automotive cages, right? So I know a lot of our competitors in this space have issues with this type of perception. So due to our photoelectric, ultrasonic, and 3D image LiDAR, we were able to assess the outer barrier of these automotive racks and the spacing in between these posts as well, the columns. And that gives us the ability to then assess, spear, and then handle these automotive cages. What you'll see also is that the stacking confirmation. So we use our image camera to assess the posts at the bottom of both the ground level or lower stack cage rack and the above to assess the posts and any type of deviation or orientation issues. And that'll allow us to either use side shift, change our orientation or direction to then safely pick up and stage. So this V&E model, this is our 20, so it's a 4,100 pound capacity. It's also available in a VE 35 and a VE 40. So the 35 model is 7,000 pounds roughly, and then the VE 40 is 8,000 pounds roughly. So we do offer this in a higher capacity uh, vehicle. So I'm gonna grab my laptop here so you can see this higher stack.
You'll also notice the valley plate on the side, as I mentioned. So we do offer auto charge. We'll showcase this demonstration later on this call. You'll see the light indication as well. So we have light indicator, audio indicator for safety, as well as blue light as well. Once the vehicle stops, I'll walk around the V&E 20 as we set up the reach truck, so you can get an idea of the safety sensors, the location, our visual and mechanical verification sensors that we offer, and just a better overall of the functionality and setup of this V&E 20. So this vehicle here, standard max fork height is 14.5 feet. Okay. So it can go close to three base high, two or four high, depending on the size of your height of your pallets, right, for stacking. So we can stack and destack up to 14.5 feet. Our travel speed is a little over 6 miles per hour. And the interesting thing about our technology is how we travel. So I know in manual forklifts, traveling forward is forks first, but the way for safety, we travel tractor first. So when we travel tractor first, we can get up to 6 miles per hour. You also notice that this vehicle has, it's based on a manual truck essentially, right? So it can be operated both fully autonomously and manually as well. So you can hop in the compartment, hit the switch to manual mode, and drive the vehicle manually. Yep. So right now, as you see, we're traveling tractor first, up to 6 miles per hour. Now we're going to showcase our pallet destacking and movement as well. So okay. So what we're going to do is go ahead and change over this demonstration here. So what I'm going to do is go ahead and change this workflow to make it from rack handling to pallet handling, and also give you a sense of how quickly in our RCS we can maybe change over the dynamics and scope of work of our vehicles. So right now it's gonna self-park right behind me. We're doing some online, mechanical changes there to make it now do some pallet handling, destack, transportation, and handling. And then right after that, we're going to showcase our VNR16, our autonomous reach truck, and then the auto charge function as well. So hopefully the chat is working. If you guys have any questions, you could just let me know in the chat. This is my first time using this platform, so hopefully everyone can see and hear me. Okay. So what we're doing is we always come up just slightly above, right? So now verifying the pallet location, orientation of the pallet, then we're going to drive in and spear. So just so I see a couple people on the call, just so I know everything's working fine on your end. I see Jack Sanborn. Can you give me a thumbs up if you hear me? Okay, perfect. All right, thank you, man. You never know nowadays, you know. So what's also unique about our technology is that we have the ability to use adaptive motion. So you notice that once we come up, we kind of change our orientation a little bit, right? It's because we recognize that the pallet is not precisely at its location, right? So if a pallet is maybe manually dropped on the ground for pickup, and it's maybe off the beaten path, askewed maybe 3 or 4 inches, or up to 10 degrees angled, we can come in, change our orientation, and then spear that pallet safely. Okay, so now we're going to set up the reach truck to do a handoff now. So we're trying to set up scenarios where you might have a dock to stock scenario, right? So the main focus for our technology is to eliminate non-value movement. In high velocity applications, typically it's, dock to stock, plant to warehouse, just non-value movements where forklift operators just hate doing and it's repetitive over a long shift structure, multiple shifts. So right now we're trying to emulate, an inbound staging, right? Dock to stock. So now the V&E or V&P stage pallets in position or dropped off at end caps, and then we're going to utilize the autonomous reach truck to do the final put away into your high bay racking. So now we're just setting up here shortly, and then we'll swing it around to showcase the VNR reach. Okay, so let me get here a little closer for you guys. Let me wheel myself over. Right, so swinging around here. Let's do this actually. So we have three different models of the VNR. We have the 14, 1.4 ton, 1.6 ton, and the 2 ton. So this vehicle right here is our 16 model. Our reach truck can go up to max fork height of 36 feet, right? So granted, it's going to derate naturally as the higher we go. So depending on the model, anywhere from 900 to 1,400 pounds we can lift at max fork height. So now you're going to see us do the high bay put away after being staged by the VNE 20. Again, all our vehicles can be driven manually if needed. Right, so this feature here is great for when you think about, I mentioned earlier, our RCS tying into your upper system, right? So allowing uh, your inventory system to manage these movements, right? So tracking through barcode scanning, someone scans in, we see it open pallet position in, bay 13 and aisle 4. We can then go and put away or retrieve that pallet. Typically, too, right? Reach truck operators manually are your uh, most costly employees, right? A lot of product damage, misplacement, racking damage as well. This kind of streamlines that approach to mitigate those safety and cost issues. Okay. So as you notice, right, there's zero infrastructure around for us to do this movement. If I scroll up a little bit, there's no reflectors, magnets on the ground. It's all using our 3D LiDAR that you see on the vehicle. And we'll do a walk around the vehicles so that way you get a better sense of the infrastructure, the layout. So you're going to do the charging? Okay. Okay. So right now we're going to get set up for the auto charge feature. So as I mentioned earlier, our robot control system will monitor the state of charge, and we want to stay between 80 and 30% state of charge at all times, right? So as we're doing work, making moves in your facility, we're going to see that state of charge using lithium ion technology, iron phosphate, self-park, self-dock. So we're going to mimic that here shortly using our VNE 20 to self-park and charge, so you can kind of get a sense of what the charging looks like and what the general area is required for that type of setup. So what I'm going to do while we get that squared away is I'm going to showcase some of the visual and mechanical verifications that we have on our vehicles. Nicholas, can you do me a favor and hold the camera for me? I'm going to show the cork tips and whatnot. So we're going to come and showcase the VNE VNR 16 here, the mechanical features. That way you get a better sense of how the mechanics work. So as I mentioned, we have a lot of different safety requirements here in our vehicle, right? So you might notice we have mechanical verification sensors here. So what this does is allows you to have the goods in place sensor. So when we come in and spear the pallet, we want to make sure it's a clean and effective pickup. If there's any type of deviation off of the pallets of these sensors that are pressurized, it's going to send an alert to our system. But once these are clicked in place, it lets our system know, hey, pallets are secure, or same for the vertical and horizontal, pallet secure, engage with the pallet, continue on its workflow. Here on the tips, though, of the forks that are standard, we have fork pressurized tips. So what happens is a lot of times there's product damage, damaged wood boards, maybe a pallet's really close to a wall or a sister or brother pallet. So when we spear this pallet, if we make any type of pressurized contact with this, it's going to send an alert, hey, not a clean pickup, re-engage with the pallet. So if I hit this right here, it's going to send an alert that we made error contact, and we'll re-engage with the pallet using side shift, fork position, since it is an option here in our vehicles. As I mentioned, we have sensors in between the forks. So for stacking capabilities, so as you look down here, we have a 360 mid sensor here to make sure that we are verifying the stacking capabilities and any type of orientation, deviation of stacking when we're at high heights for the reach truck or just limited height with our V and P and V and E. We have our safety height sensor here on the mass, both laser and physical as well on all our vehicles with stacking capabilities. We have emergency e-stops at different locations, both left and right side. Come around here, as we mentioned, we have our blue lights. We have our light sensors as well, different queuing for idle, engage on a mission. So that way there's different verifications of notice and let individuals and your floor employees know what's going on around the vehicle at all times. We have our MHI here, touch screen to hit for reset, restart, switching over to manual mode, checking different data points inside of the vehicle, outside of the RCS that's constantly monitoring it. So again, just another option to understand different logics and data points within the vehicle. The operator compartment. So as I mentioned earlier, you can drive it both manually and autonomous at any given point in time. So it's another great feature. Different blue lights here, and then again, the emergency e-stop. And then we have our safety e-stop down here, another one, and then our valley plates for auto charge. So these type of features and devices are pretty much standard in all of our vehicles, ranging from the Q, the P, the E, and even our stackers. So I really wanted to showcase these to give you guys a better sense of the safety and dynamics of our vehicles. So then we're going to go ahead and show the auto charge here. And it's going to get stuff right here. So if you come over to this wall, you're going to see our auto charge station. So as I mentioned earlier, all of our vehicles are monitored through the RCS system, right? So we want to stay between 80 and 30% state of charge. So once we recognize that issue, we're going to send the vehicle to its home location or charging location. It's going to self-park, self-dock, and charge. So as I mentioned, tractor first is backwards, right? So it's going to travel this way. That's its forward, and it can reach up to 6 miles per hour in speed, the VNE 20. So now we're going to go ahead and self-park ourselves, and we use proximity sensors to understand the spacing requirements for the charging. You see the tiller arm comes out, makes connection with the valley plate, and then the charging will turn to green and start charging. You can hear it actively charging right now. So again, we want to get up to 80, 30% state of charge at all times. Once we get up to 50%, we'll cut out and go back out into the workforce as needed. So when we do our fleet calculations, start designing your project, we want to understand the throughput, peak demand requirements, travel distances, so that way we can really fine tune a solution to automate those manual workflows. This auto charge can also be set as manual too as well. So you'll see there's some cables here and a standard Euro connector. So if need be in a punch, if there's any type of issue mechanically with the auto charge, you can still manually make connection and plug up your vehicle with VisonNav Robotics. Okay. All right, perfect. So I'm going to take some time here to last maybe 15 minutes or so, answer any questions if you guys have any. Again, I'm not sure if the chat is working. I haven't seen any questions come through yet. So actually, let me get my mouse here. Are there any questions from anyone? And is the chat working? Jack, you're my ruler here. Is it working? Yes or no? Thumbs up for yes, thumbs down for no. Sorry, are you speaking, Jack? I can't hear you. Yeah, I do not have audio on my end for you guys. How about now?
Yeah, there we go. Can you hear me now? I'm getting a green bar.
Okay, there we go. Let me hit this switcher. Sorry guys, it's a new platform for me. So if I turn on this button for everyone, I think I might get some sound going. All right, there we go.
Can you hear me now?
Yep, I can hear you, Jack.
Okay. Yeah, I was telling you that the chat, I'm not quite sure where that's at. If anyone else in the audience sees that. I personally didn't have anything for the chat during the call, but
okay,
something I guess to look into.
Yeah, I can't find the chat either.
Yep.
Yeah, and I appreciate it. Again, this is a new platform, so you're my first guinea pigs for this. So apologies and appreciate you guys jumping on. But I think I have your audio working. So if you guys do have a question, you can just just blur it out to me and I'll answer it.
Yeah, when did you guys start in North America? I missed that at the beginning. I know you mentioned it.
No, yeah, great question. So I would say our first trade show was Modex of last year, I believe. So close to almost a year coming up. I'll say 8, 9 months respectively. We've been here in North America. Primarily,
Okay.
we're founded in 2016 in China, and since then we've deployed over 2,000 robots across 350 projects. So ranging from manufacturing, 3PL, food and bev, automotive. So making a strong headway here globally, and just now hitting our stride here in North America. Received some recent POs and deploying actively right now. So really excited to bring this technology here to North America.
Yeah, very nice.
Yeah, so I'm gonna just blurt out some names and see if anyone has a question. I got Uriah, Mark, Keith, Lauren, Mike, Corey, Ray. Any questions at all? Did you guys find this valuable at all?
No questions. I enjoyed it. Excellent showcase here.
All right, perfect. Yep.
Agreed.
Again,
Nice
this
demo.
this demo space is just north of Atlanta. I'm in Ackworth, Georgia right now. So if you guys ever have any interest of coming here in real time and seeing and kicking the tires, so to speak, we can set up a scheduled meeting to do a more deeper dive into technology, an overview, and then showcase the vehicles in person. I know I kind of breezed through this, but we have an hour slotted for this this call, and then we'll do a follow-up later this afternoon at 2 Eastern time. All right, so if there's no other questions, I'm gonna go ahead and end the stream. Again, I'm going to re-engage on this same platform at 2 p.m. this afternoon. So if you want to send the link over to another colleague, a team member, do not hesitate to do so. You can also find me on LinkedIn, obviously. You can reach out to me with any questions, thoughts, concerns, ideas, and love to connect and chat with you as well. So with that being said, enjoy the rest of your day, and hopefully I'll talk to you guys all soon. Thank you.
Thank you.
Thank you.